guys, so today we're going to be talking about the characteristics of your graph of sine and cosine, and we're going to be doing mostly amplitude and some transformations, and I'm going to get briefly into period, but we'll talk more about that tomorrow. So these are your parent functions for sine and cosine, okay? The difference, they look very similar. They're both just kind of like squigglies, okay? The main difference, the way you can tell the difference between the two is that sine goes through your origin here, okay? And cosine goes around like that. It does not go through your origin here. Okay, so that's how you can tell the main difference. Let's talk about domain and range, okay? So both the sine and the cosine function have the same domain and range, okay? Your domain is going to be all real numbers, right? Because that's your x, your domain, and it's just going to keep going and going and going and going forever, like squiggling and bouncing forever. Okay, so they're both, your domain is x such that x belongs to the set of all real numbers, okay? So all real numbers. Your range is y such that y is between -1 and 1. So you can't really see the 1 and the -1 here, but this is 1/2 and this is 1. So the functions just bounce between -1 and 1. They're never going to go greater than 1 or down past -1, okay? I'm going to be putting a question in the homework. I want somebody to explain to me why sine and cosine will never go past 1, will never be greater than 1, or the absolute value of their amplitude here, their A. So I'll be posting that, and you can try to let me know what you think. Okay, period, I'm going to talk more about this tomorrow, but period of both of their periods are 2 pi. And what period is, I think I'm going to also post a Khan Academy about explaining period to you, but I think sometimes it's easier coming from my words. So think about period as a cycle, okay? So you would look at this, it's like a pattern, right? This function, it's just going up, right? Up here, and then down below, and up again, right? So one hump wouldn't be a pattern, wouldn't be the cycle or the period, right? It's not. You'd have to think of it like, when does it repeat again? So like, I'm going to go up, and then I'm going to go down, and then I'm going up again. Then it would repeat up and down and up again. So maybe it's better if I start on this side. So one little cycle here in our period would just be an up swoop, like an up bump, and then a down bump. And then it's going to repeat again. An up bump, and then a down bump, right? So the period is 2 pi, and that's because if you look at this piece right here, right, this is one cycle. It goes from 1 pi to 2 pi. You have to look at the x-axis, okay? And again, I'm going to post some more stuff on period later, okay? So 1 pi, this is 1 pi here, and this would be a 2 pi, that'd be 3 pi, 4 pi, right? So this cycle, right, this hunk right here goes from 0 to 2 pi. So the length, the period would be 2 pi. Okay, same thing for cosine. You could really start from any piece of the graph. Okay, so if I wanted to start from, let's see, here might be a good place to start. It's going to start from here, and it's going to go up and down, and then it's going to repeat up and down, and then it's going to repeat up and down. So again, if you look at this period as going from here to here, it's also, this is 1 pi here and 1 pi here, which is 2 pi. All right, so again, I'm going to talk about more of that later. And then amplitude is much easier, okay? Amplitude is basically how the distance, it's always absolute value, so how high up the graph and how low. So your amplitude is 1. So you go to the midline, right, which means like, where is the graph cut in half? This highest is going to go is 1 here, and the lowest is going to go is down 1 this way. So the amplitude is just 1. 1 this way, 1 that way. All right, so they have the same domain, range, period, and amplitude. Okay? So here's another way to look at it. The parent functions can be looked at, if you remember when we did transformations, y equals a times the sine of bx, and y equals a times the cosine of bx. Okay, so here's an example. I have a sine function here. So your a indicates whether it's going to be a stretch or a compress. right? So when your A is greater than 1, right, the absolute value, then you're going to have a compression. When your A is between 0 and 1, right, like maybe a fraction or something, the absolute value, it will go, it's going to come like, it's going to look more shorter. Oh, I'm sorry, I said a compression for this first one. When A is greater than 1, you have a stretch. It's going to stretch up, okay? And when A is less than 1, you're going to have a compression. So it's going to be kind of like smushed downward, okay? Sorry if I just confused anyone. So here's an example. My parent function of the sine goes from 1 to -1. So it would just be bouncing in between here, okay? If I have y equals 3 times sine of x, that means my amplitude is 3, okay? Whatever here, your A is your amplitude, okay? So because there's a 3 there, that means now the function is going to go up to +3 and down. You see how your y goes down to -3. So the amplitude is just how high or how low it's going to go, okay? Your distance. So it's absolute value. All right. If this were, say, a 1/3 or a 1/2, that means it would get even shorter in here. It would only go up to 1/3 or 1/2, you know, above and below your midline. Okay, if it went up to 4, it would go up here. Actually, I think I have another page. Oh my God. All right, here's another example. The blue here is your parent function of sine, y equals sine x. Okay, if I had y equals 2 sine x, that means A is 2, right? My amplitude is 2, so that means the graph's going to go up to 2 and down to -2, okay? So it goes by your midline, right? Wherever the graph is right in the middle, whatever's up here is your amplitude, or down below there, okay? And again, your period is just one cycle of the graph, and it's going to just keep repeating and repeating, okay? Same thing for cosine. The blue here is a graph of your cosine function, okay? And y equals 2 cosine would mean that instead of going from 1 to -1, the amplitude would be 2, and then you're going to go up to 2 and -2. All right, and then one more thing we're going to talk about today. This is just another example of the graphs. Here is your parent function of sine, and then if you have an amplitude of 2, it would be up to 2. If you had an amplitude of 3, it would go up to 3. If you had an amplitude of 4, up to 4, and so on and so forth. Okay? Okay, now reflections. Just like we did with, I don't know, quadratic functions, right? Or any function. If I have this darker line is your parent function of sine, y equals sine x. If I were to make it negative, right? Negative sine x means it's going to reflect across the x-axis. So it's like I'm taking this and I'm just flipping it over. So it's just kind of facing the other way. Okay? It flips over. So that would also be applied. Okay? Same thing for cosine. Your blue one here is the graph, oh, I'm sorry, your red one here is the graph of cosine, your parent function, right? And then if I had negative cosine, it's going to take it and it's going to flip it over, right? And it's just going to keep squiggling and squiggling and squiggling. All right, so that's going to reflect. I think I'm going to post this for you to do. This is a matching. So I'm going to post this for you to do. Match each function with its color on the left. So I'm going to post this for you to do. I'm only going to have you do, I think, some amplitudes and reflections right now. And then I'm going to get more into the periods. Okay, so this, and then I'm also going to ask you to explain to me why sine and cosine will never be greater than 1 by itself, without being stretched or compressed. Okay, have a great day.